Right, Jenny here. We're carrying on the microbe story. EM1 is really an amazing product, and it's used across so many different types of applications, although just here we will talk about gardening applications in a normal home environment. What I want to talk about here is the actual microbes that are involved in EM, and this is the specific EMRO Japan recipe. I'm not talking here about all the homemade recipes that people try, because that's just a completely other story, and none of the research applies to that. The research applies to this specific recipe, which has got 30 years of history behind it and an awful lot of research. So this is a group of this is made up of 5 different types of bacteria and fungus, and I'm going to read them out because I can only remember one of them on my own. There are two groups of lactic acid bacteria. The label's in Swedish, so I'm translating. 2 groups of lactic acid bacteria. They are Lactobacillus plantarum and Lactobacillus casei. Casei is one you get quite often in yogurts and things like that. It's a fairly standard one. The fungus, one group of that, is called Saccharomyces cerevisiae, and that combination of the bacteria and fungus is what makes this so special. Then we have 2 other types of bacteria which are more used which are more appropriate for actually in the soil when the plants are growing, and these are really, really valuable for the plants, but they're maybe less important in the actual fermentation. The other 2 groups are really important in the fermentation, but these 2 groups are super valuable. And these are called photosynthesis bacteria, and that is because they can actually take nitrogen and carbon dioxide. They help plants take nitrogen and carbon dioxide out of the air and any other place where it might exist around them, in the soil even, and turn that into energy. Incredibly valuable. These 2 bacteria are ancient. They've been around since time immemorial, doing good work. They helped the planet take shape when we just had a mass of poison gases and minerals, hard rocks and things that needed to be broken up, converted into something organic. These were the 2 microbes that did it, bacteria groups. And these are called Rhodopseudomonas plastris and Rhodospirillum rubrum. And those 2 we could actually do a whole story on, because they're very, very interesting and incredibly valuable in the garden. So how many microbes are in this bottle? Well, that's just like off the scale, so many zeros. Let's see now. It's the standard thing that we always say is that there are enough microbes in a teaspoon. There are more microbes in a teaspoon than there are people on the planet. And there are so many zeros in that whether it's a little bit this way or that way really makes no difference. It's just unbelievably many. In this particular state, in EMA, the microbes are dormant. They're not active. They are just hanging around until something good happens to them, which means that it's a really good way of storing it. So this actually can stay in a fresh state for at least 6 months, actually longer, but it can be guaranteed for 6 months. The important thing is not to let air get into this bottle, so once you open it, it's quite good to use it fairly directly, because air is always oxidating the processes and helping to age them, the same as oxidation ages us, oxidation ages bacteria. So we have zillions of bacteria here which are dormant. They are activated when they come in contact with sugar. Molasses normally is what's used, and if we mix these 2 together in water, they will become active and ready to work in the garden if you spray them out in whatever shape or form. Google up those bacteria groups. I have them on the website, bokashiworld, and a couple of other places, and check them out one by one. They're actually incredibly interesting. They do so much good work in the garden and in so many other places. You know, nature is made up of many different types of microbiomes. We have a microbiome in our stomach. There is a microbiome in the soil. There is a microbiome in the water, and on and on and on. And this is why EM can be used in so many of these different environments, because it is contributing to a healthy microbiome. If we have a healthy microbiome in ourselves, in the soil, in the water, in wherever, chances are that everything will work out so much better for us. This is the basis of good health. So that is the foundation of EM1, the microbe groups, and we'll go on from there and talk about how to make activated EM and so on.